Hello, today I'm going to show you how to place the load-bearing towers on a Rio bridge project using our newly created load-bearing tower placing tool and helper Dynamo script for bridge pre-processing. The bridge is around 220 meters long and it has 14 spans, and the height between the terrain and the superstructure varies between 4 and 10 meters. This is our typical solution in AutoCAD, and in order to create it in Revit we need two things. We need the center line of the bridge around which we're going to align our helper families, which will be later converted to 3D towers. And the second thing is we need a surface from which we can obtain the coordinates for the towers. The script can automatically take coordinates from the surface above them, but the problem is in these areas where the bridge goes up and the tower needs to finish here instead of here. So that's why we need to create something temporary up to this level where the towers would end. And for that we will use our custom-made Dynamo pre-processing script. To create the center line of the bridge, we need to create a mass body, and in this mass body, using this tool, we can pick the outer lines, outer contours of the bridge like this. And once we do that, we can go outside of the mass body, hide the substructure of the bridge, then go inside back into the mass body, and we need to offset with half of the width of the bridge, which is 4.4 meters. So we click on this and offset inwards 4,400 millimeters, and then we can delete the outer line, and that's it. This is the center line of the bridge. And with the center line split, now it's time to place the center points for each tower. You can see that the towers are roughly 3 meters apart and about 1.5 meters from the pier. So in Revit, we click one of the spans and then we create a divided path. Divided path is basically putting points on top of the center line, and these points can be controlled by parameters. We have a beginning indent and end indent. This means where the first and the last point will be in relation to the end points of the line. And then instead of fixed point, we can use maximum distance, and this would be, let's say, 3000. And these are the points at which we're gonna insert our towers. And with that prepared center line, we can start our load-bearing tower placing tool, with which we can form the bridge. It's located in Community Tools, Load-Bearing Towers. In the top section, you can select the system. Currently, it's D3. Here, you can choose the number of spacings. So you can go from 1 up to 10 currently in this system. And then from here, you can set up the top structure, the orientation of the heads, the combination of the frames, and the type of the family, which in our case is going to be adaptive. And if we look at our typical section, we will see that it's 1.5 meters, then 1 meter empty space, then without diagonals, then 1 meter and 1.5 meters, then 1250 and 1500. So how we configure that in our software is in here we need to have a couple more spans to 6. Then the second one should be no diagonal, and it should be 1250, then 1500, then 1000, and then this one doesn't have diagonal as well, and it's 1000 and 1500. So here we can increase the capacity by using only 1200 and 900 millimeter frames, and we click create. And once we create this helper family, this is a visual representation of our tower. We hover over and we place it in between the points, and we start placing them like this, one by one. And once we place them everywhere, we can align them with the simple align tool from Revit by showing the point, and then this one, and then this point, and so on until we have the entire layout. Once we align all the helper families throughout the entire length of the bridge, we can go to the next phase, which is naming them. Each tower has by default a name of T0. So renaming 100 plus towers would be quite a tedious job. So that's why in our tool we have on the second tab a tower naming section where we can choose the prefix and the starting number of the naming. So basically here we just need to click the button, select all towers, click finish, and in just a couple of seconds we should have completely renamed towers. So if you look now, it's T1, T2, T3, T4 all the way to the end, and the last tower is T118. And now the next step is to add the temporary surfaces underneath the soffit of the bridge, which our other script will use for getting the top coordinates for the heads of the towers. So we created a special Dynamo script for pre-processing of the bridge. It's quite simple to use. We just have to press the play button and select the bridge and the center line, and it will create these small rectangular surfaces underneath the soffit, which can be used afterwards for getting the coordinates for the towers. So the process is simple. We just select the number of towers, in our case 9, press play, and we wait to have another set of temporary surfaces underneath like this. And there you go. This is how it's done. And now, once we have all the temporary surface on top and the topography at the bottom and the helper families in the middle, all we need to do is just run the script and use the third tab to generate 3D towers. And all we need to do is select everything, including the top surfaces, bottom surfaces, and the helper families, and then click finish. This whole thing should take roughly 3 minutes because the first portion that I made already took 45 seconds. So I'm going to just pause the video and show you the result. And the tower generation finished. These 3 spans took about 3.5 minutes. So the total was about 5 minutes for roughly 1/3 of the bridge. So the whole bridge will probably take another 10-12 minutes maximum. These were around 5,000 components placed in 5 minutes, and 32 towers that we generated. As you can see, they go by the outline of the bridge, and here is with the actual bridge in place. But because this is 3D, it's a little bit difficult to see, so I'm going to show you the plan view. This is how the generated towers look like with their respective numbers. And we have a section, and in this section you can see that this pretty much looks like what we had in AutoCAD. The towers are following the terrain, and they're following also the inclination of the bridge. And a few more useful features that we have. One is to see the material list. It's already done in the schedule automatically at the time of generation. You just need to open it. This is ready to go material list for the entire bridge, split by tower numbers, so you can see T1, T2 all the way to the one that we generated, which is T32. If we did the whole bridge, it will be all the way until T118. And the last thing is the fourth tab, which is export. You just click export, select all the towers that they were generated, and click finish. And this will automatically start Excel and starts building a Excel spreadsheet in which broken down by towers. We have the leg number, we have the base or the foot XYZ coordinates, the head XYZ coordinates, the extension of the base or the foot, extension of the head, and the leg, the length of each and every leg. This is again broken down by towers, and you can see that the tower is generated in real time a little bit slower. So I suppose it's going to take another 30 seconds or so. So we're not going to wait for it. But in any case, that's pretty much a summary of making bridges with our load bearing tower placing tool and pre-processing DynamoScript. Thank you.